So when working with CSS, we'll be working with a lot of different unit types. These are different ways to express values in CSS. The different units will revolve around what type of data we're storing. So if we're storing a numerical value, we might use pixels or percentages. If we're using a color value, we might use hex or RGBA. So for distance and positioning units, we'll have a couple different options. The first we can use is px, or pixels. This might look something like 20 px, or 20 pixels. Pixels are in terms of screen size, so 20 pixels will be a distance of 20 screen units. We can also use em, which is written in something like 1.3 em. These are relative to the root and inherited font size. So if we say the parent element has a font size of 12 pixels, 1 em in a child element is going to be 100% of that font size. So 1.3 is a bit like saying 130%. We also have REMs. REMs are relative to the document root. So they work like EMs in that they're relative to an inherited font size, but they will always look to the body or the document for their font size inheritance. So giving a parent element of an REM unit is going to not affect the actual percentage calculation. We also have actual percentages, which will be written something like 85%. This means 85% of the parent's width. So these are our basic units for distance and position. So for positioning something absolutely, we can use any one of these values. Or if we want to size anything, we can use that. Font sizes, anything like that. So I guess this would also include sizing. So we'll be able to size and position and basically control where things are going to be based on using these different unit types. We'll also be defining colors. So these will be background colors or font colors or border colors. Any sort of place where we could change the color of something without using an image, we'll be using one of these color units. One of the most common is hex. Hex starts with the hashtag and follows R, R, G, G, B, B. These are hexadecimal colors, so they'll go from 0 to 9, and then A to F. So if we wanted to express white in hexadecimal, we would use F, 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 F. 6 Fs. So we have the R, the G, and the B component. We can also shorthand hexadecimal if the 2 R values are the same, the 2 G values are the same, and the 2 B's values are the same. So this could also be expressed as FFF, because we're shorthanding that value. As FFF is a full white color, 000 will be a full black color. HTML also gives us access to string colors. So if we're trying to say something in a more readable way, instead of using hexadecimal, we could say something like black or white. The browser has a series of these built in, so we could say color, black, and the browser would know what to do. We can also define things using RGB. RGB uses, instead of hex, it's similar to hex, but instead of using 0 to 9, A to F, we're using 0 to 255, 255 being full white, 0 being full black. So we could define a color as RGB, and then pass it the R channel, comma, the G channel, comma, the B channel. So we could say that black is 0, 0, 0. Or we could say white is 255, 255, 255. So this just allows us to express our colors a little bit differently using this format. Finally, we have RGBA. RGBA isn't widely supported across all browsers, so you want to check the Can I Use site, caniuse.com, to see what the actual browser support is for this feature. But what this allows us to do is define our colors as RGB, but also add an additional A value, A for alpha. So if we wanted a background that was semi-transparent black, we could use background color RGBA and define a semi-transparent value for the alpha channel. So just like RGB, RGB will take in 0 to 255, while the alpha channel will actually take in a decimal. So if we wanted a semi-transparent black background, we could do 0, 0, 0, 0, 0.5. And this would give us a 50% opaque black background.